Okay, we'll be focusing on coordinate geometry today. One of the first things to learn is the Cartesian plane. Understanding the Cartesian plane, what is important here is to understand that how you read the Cartesian plane is how you write your coordinates for each and every point that you'll be using to calculate either the gradient, the midpoint, the distance, and so on. Now, in terms of coordinates, this is how you write your coordinates. You start with your x value and then you come with your y values. These are your x values. When they get to 0, they become positive on the right, they become negative on the left. The same with the y axis. The second part of your coordinate is your y. Then from 0 going up, your y is positive. From 0 going down, your y is negative. Now, let's assume that we're given a point here. They can name that point A. Now, if you want to give coordinates of point A, you're going to say the x value, so remember we start with the x value, the x value of point A will be, you check here, it's aligned with number 1, therefore it's 1, and the second value will be a -1, and therefore this is your coordinate for point A. Usually it's best to actually move with dots like this, draw dotted lines going down and draw dotted line going horizontal. You realize they meet at this particular point. The same could have been done on this part to identify the coordinates of A. But if you are working with a Cartesian plane that is up to scale with well-drawn lines on a graphical plane that is clear, you don't need to draw these dotted lines. You will see which coordinate is X and which one is your Y. Now, let's say you are given the second point to be somewhere around here, and they name that point B, and you must give coordinates to point B. Again, you start with your x-axis, therefore the x value there that is aligned with this point is 3, and the y value that is aligned with the same point is a -2. So you've given coordinates to point B as well. So this is how you read these points that are given on your Cartesian plane. Now, you're going to use these points to calculate the gradient, to calculate anything that they want you to calculate. You're going to use points or coordinates that are given on the Cartesian plane. So you need to use those coordinates to calculate whatever that is required. Now, let's assume that we're given A and B as we have here, and we're supposed to calculate, number 1, the gradient. Let's start with the gradient. So they're saying we need to calculate the gradient between point A and point B. Remember, gradient is your slope. So when we calculate the gradient, we're looking for the steepness of this particular slope. And in mathematics, we use symbols. And the symbol for gradient is a small letter m. And the equation for gradient is change in y over change in x, which can be written like y2 minus y1 all over x2 minus x1. This is the change that we are talking about. Therefore, another thing that is advisable is, now that you have your coordinates, I would always advise that you have 2 points, point A and point B. To avoid making mistakes, you write x1 for this x of A and x2 for the x of B. And then you are going to have y1 for the y of A and y2 for the y of B. In this way, when you substitute in any equation, you don't make a mistake and you find yourself substituting an x2 instead of an x1, or substituting a y value instead of an x value. Now let's calculate this gradient. So we're going to say, okay, what is y2? Y2 is a -2, therefore we say -2. In the equation, there's a negative sign there. You put that negative sign. You go to the y1. It has also a negative sign. Then you put the bracket for substitution of that -1. And then you put it there. Divided by x2, we have 3 minus 1. And therefore, -3, negative times negative is positive. Therefore, it's a -2 plus 1. It's a -1 all over 3 minus 1, which is 2. Now we have the gradient of, okay, here you could have just written A and B to show that you're calculating the gradient of A from A to B, just so that you don't find yourself mixing up information. So now we have the gradient. Even if they've given you a different point, giving you another point this side here, and say you have point D here, which has coordinates -2 and -1, which is here, and another point at the top there, a point here, they call that point F, and they say it's 0 and the y value there is 2. Then they want you to calculate the gradient between these 2 points. Then you were going to do the same thing and say, okay, my equation is small letter m. I'm looking for the gradient from d to f. It's d to f, y2 minus y1 all over x2 minus x1. This is equals to, then you label your coordinate again. Then you say, okay, for d this will be my x1, so this will be my y1. For f this will be x2 and this will be y2. So for substitution you go for y2 is 2, then you have 2 minus y1, which is -1 all over x2, which is 0, minus x1, which is a -2. Therefore you have negative times negative, it's positive. Therefore you have 2 plus 1, which is 3 all over negative times negative, it's positive. 0 plus 2 is just 2. So again we have the gradient from this point to that particular point. Basically that's how you do it. Now let's move to the next one. Okay, let me not remove this one first. The second one, we're going to look at the midpoint. Okay, let's assume that the midpoint of line D to line F is here. This is the midpoint. So now you're looking for the midpoint, and okay, the midpoint, and the symbol for midpoint is capital letter M, and the equation is x1 plus x2 all over 2, y1 plus y2 all over 2. This is the equation of the midpoint, and now we are looking for the midpoint from D to F, and therefore we're going to say, okay, let me just write it here. Midpoint from D to F. And so we already identified which one is x1 and which one is x2. So here we just substitute. So we're going to say, what is x1? x1 is a -2 plus what is x2? x2 is a 0 all over 2. What is my y1? My y1 is a -1 plus my y2, which is just a 2 all over 2. Therefore, -2 plus 0 is just a -2 all over this 2 is 2. -1 plus 2 is a +1 all over 2. And therefore, the midpoint between D and F will be -2 divided by 2 is just a -1. And then we have 1 over 2 here. So this is the midpoint of DF. Now let's go to the third one, which is the distance. If you're looking for the distance again, the distance will be saying we want a distance from, let's use this one, from A to B. If you're looking for the distance from A to B, we can say, okay, distance from A to B is equals to, the equation for distance is x2 minus x1 all squared plus y2 minus y1 all squared again. And therefore, now we're going to substitute. What is my x2? My x2 is 3 minus my x1, which is just a 1 all squared, plus my y2 is a -2 minus my y1, which is a -1 all squared. Again, we're going to have this one is 2 squared plus -2 plus that one gives us a -1 all squared. Then we're going to have 4 plus 1. Therefore, the final answer is root of 5. So it's root of 5 units. This is the distance from point A to point B. They're saying you must provide the angle of inclination. They want the angle of inclination. In this case, we're given the angle of inclination as theta. The angle of inclination, it is the angle that a line makes with a positive x-axis. And in this case, that line starts from 0 here, the origin, and then reaches point C. Remember, point C, it is the midpoint of point DF. So if they want the angle of inclination, we know that they're going to use tan of theta is equal to m, and m in this case, or not in this case, but m in this equation, it is the gradient of that line of interest, the line that is creating the angle theta in this particular case again. So first we need to get the gradient, which is our m. This is the gradient of line OC. That is the line that the angle is actually created on. So we're going to say, okay, m of OC is equal to change in y over change in x, and then this is y2 minus y1. Therefore, y2, let me just write it, it's y2 minus y1 over x2 minus x1. And in this case now we are having 0 is to 0 for the origin. And let's label this one as your x2 and your y2. Therefore, this will be your x1 and y1 for the origin. Therefore, y2 will be a1 over 2 subtract y1, which is 0 all over x2, which is negative 1 subtract 0. So this is a negative, it's a positive 1 over 2 over a negative 1, and therefore the final answer becomes a negative or 1 over 2. So this is our gradient. Therefore, we're going to now substitute the gradient in the equation. Tan of theta is equal to negative 1 over 2. Then theta, we divide both sides by tan, then theta will be equal to into that, and then theta will be negative 26.565 degrees. Now the answer that you get there, because it's negative, you're going to add 180, because even if you can just compare on the diagram, you can see that this angle here is greater than 90, because already here we know that the y-axis and the x-axis, they intersect at 90 degrees. Therefore, the angle of interest, which is theta, is greater than 90. So 26 will definitely be the acute angle on the other side, not the obtuse one on the top of this particular line. Therefore, when you add 180, you get theta to be 153.43 degrees. So you found theta to be 153.43 degrees.